still on conservation of linear momentum. We'll take a couple of examples. Now we just want to take a little recap. Remember that the law of conservation of linear momentum states that the momentum before collision, PB, should be equal to the momentum after collision. Alright? Now, we were able to arrive at these formulas, and we said that if the two objects separate after collision, we're going to have m1u1 plus m2u2 being equal to m1v1 plus m2v2. If they coalesce, we're going to have m1u1 plus m2u2 is equal to m1 plus m2v. If they move in opposite directions before collision, we're going to have a negative velocity, and if one object is stationary, we're going to have m1u1 is equal to m1v1 plus m2v2. So, let's take a couple of examples. Alright, example 1. A car of mass 60 kilograms moving with a velocity of 5 meters per second due west collides with a car B of mass 50 kilograms moving with a velocity of 60 meters per second due east. After collision, the car A moves with a velocity of 4 meters per second due east. Find A, the velocity of car B immediately after collision, and state its direction. B, the change in momentum of the cars A and B respectively. C, the time it takes car A to stop after collision if it's moved with a constant retardation of 0.25 meters per second squared. Okay, we'll start by stating our formula. Now we see that they are moving in opposite directions, but we can state the formula as a positive number. Okay, m1u1 plus m2u2 is equal to m1v1 plus m2v2. Now, because of the nature of the question, if we consider our cardinal points, we have north, we have west, we have east, and we have what? South. Now let's consider westward movement negative and eastward movement to be what? Positive. So with that in mind, let us put down our values. Our M1, the mass of car 1 or car A, is 60 kilograms. Our M2, or let's finish with M1. Now, the initial velocity, it says due west. That is negative. So, let's write negative 5 meters per second. And then we are given our final velocity v1. We said it says if after collision the car A moves with a velocity of 6 meters per second due east, so that is also positive. 4 meters per second due east. Now let's go to the second car. M2 is 50 kilograms. U2 is 16. It says due east, so it will be positive. And V2, we do not know. Now we state our conservation, M1, we've stated it already. So let's do our substitution. We're going to have 60 times negative 5 plus 50 times 16 should be equal to 60 times 4 240 is equal to 50 V2. Alright, so if we have 800 minus 300 minus 240, what do we get? We should get 260. And this is equal to 50 V2. If we divide both sides by 50, what do we get for our V2? We are going to have, let's divide 260 by 50. We are going to have 5.2, and this is velocity, so this should be meters per second. That's for the first part, the velocity of car B. Now, it is positive, so we can say that the direction is due east. If it were negative, we would have said it is due west. Now, the second part is the change in momentum of the cars A and B respectively. Okay? Now, we know that change in momentum or impulse, the same thing, is given by M into brackets V minus U. Now, for car A, we are going to have M1 into brackets V1 minus U1. So our M1 is 60 into brackets V1 4 minus U1. That is negative 5. So what will we get? We are going to have 60 times 9. 60 times 9. What is 60 times 9? 6, 9, 54. And this should give us 540 kilogram meters per second. Let's go to the change in momentum for car B. We are going to have M2 V2 minus U2. Now our M2 was 50, and we found V2 5.2 minus U2, which is 16. So let's compute this. What is 5.2 minus 16? This will give us negative 10.8. Now let's multiply times 50. We are getting negative 540 kilogram meters per second. Go and find out, what does it imply if momentum is negative? Alright. Now let's look at the last one. It says the time it takes car A to stop after collision if it's moved with a constant retardation of 0.25 meters per second. What is retardation? Now, retardation is slowing down. Retardation means slowing down. And it is the opposite of acceleration. It's the opposite of acceleration. Okay? Now, if acceleration is positive, retardation will be negative. So we are going to have A to be negative 0.25 meters per second square. Now they are asking us for time. So let's use our formula V minus U over A. And we are talking about the car A. So what is V1? So it will be V1 over U1. Huh? What is V1? after collision, so the saying it will stop. Let's go back to the question. It's saying that the time it takes the car A to stop after collision. Now after collision, this was car A's velocity. So now this one will become a U1. And after collision, it means that it came to a stop. If it came to a stop, our V1 will be 0 meters per second. Okay? So let's consider that. So our V1 is 0. And our U1 is 4 because we are looking at after collision, not before collision. Our A is negative, that's a retardation. We are looking for the time. So we're going to have 0 minus 4 all over negative 0.25. Okay? So we are going to have negative 4 divided by negative 0.25. And this will give us 16 seconds. I hope you had that when you tried it on your own. Okay, let's look at another example. A ball of mass 1 kg strikes a cushion of a sofa perpendicularly at a speed of 5 meters per second and rebounds at 2 meters per second. What is the change in momentum if the total time of impact is 0.02 seconds and the force of the cushion is constant? And the force of the cushion is constant. All right. We are looking for change in momentum, which is also called impulse. Now the change in momentum is given by m into brackets v minus u. Okay. Now we can even try and draw a diagram. If this is our cushion and this is the ball, the question says it strikes the cushion of a sofa perpendicularly. So it strikes the cushion perpendicularly and rebounds at 2 meters per second. So when it strikes the cushion, it rebounds. It rebounds. We could strike the cushion and then rebounding means it is moving back in there. So it's bouncing back. It's striking the cushion and bouncing back. So now if striking the cushion is a positive direction, rebounding will be a negative direction. All right. So let's put down our values. Our mass is 1 kg. Our initial velocity u is 5 meters per second. Our final velocity v. Now this is going to be interesting because it needs to be negative 2 meters per second. So let's find our change in momentum. We are going to have 1 into brackets minus 2 minus 5. And so this will give us minus 7 kilograms meters per second. Now we are asked to find what is the change in momentum if the total impact of the force is constant. Now there was a second part I think I missed. We have to find the magnitude of the force. So let me just put it here. Find the magnitude of the force. Okay. So f of t should give us our m v minus u. That's the impulse. Okay, so that if the time taken is 0.02, and that will be equal to the negative 7, which we already found, then our f will be negative 7 over 0.02. Now when we divide negative 7 divided by 0.02, we're going to have negative 350 n. Did you pause the video? Pause the video. Let's look at this one. Always pause the video after the question, and let's see if you get the same thing. A bullet of mass 0.02 kg traveling at 200 meters per second hits a stationary block of wood, passes through it, and emerges horizontally with a speed of 50 meters per second. If the block is free to move on a smooth horizontal plane, find the speed with which it moves after the bullet passes through it. Okay. So let's see, this is the bullet. It passes through the block of wood, passes through it, emerges horizontally with a speed. Now, the impact also causes the block to also move. So now we are seeing that they are moving separately. Okay, so we are going to use our formula m1 u1 plus m2 u2 is equal to m1 v1 plus m2 u2. Now they said if the block is free to move, so we want the velocity of the block. So let's start with the mass of the bullet, 0.02 kg. The initial velocity is 200. It started with 200 meters per second. Final velocity 50 meters per second. Now let's look at a block of wood. What is the mass? I think I missed the mass. A stationary block of wood, the mass is 5 kg. Sorry. So M2 is 5 kg. Now U1 will be 0 because it said stationary. It's not moving. And we are looking for V2. Okay, so let's do our substitution. We're going to have 0.02 times 200 plus, now this will call for the M1 U1 formula. So this is all going to be 0. So let's even forget about it. I will say this is equal to, so this whole part is 0. Or you want me to write it? No problem. I can write it. Plus 5 times 0 is equal to 0.02. Final velocity is 50 plus 5v2. So what is 0.02 times 200? This will give us 4. 4 plus 0 is equal to, now 0.02 times 50 will give us 1 plus 5v2. So what is 4 minus 1? That is 3. 5v2. So 5v2 is equal to 3. Let's divide both sides by 5. So our v2 is 3 over 5, or 0.6 meters per second. Alright, I want you to try yourselves question 3. A bus of mass 4,000 kilograms traveling at 15 meters per second collides with a car of mass 1,000 kilograms traveling at 20 meters per second. Assume they coalesce after collision. Find the common velocities the vehicles were moving, if the vehicles, were moving in opposite directions before collision. So with opposite, I'll just give you a clue. M1U1 minus M2U2 will be equal to M1 plus M2V. They are moving together. Okay? So try your hands on this one. Thanks.